Hi, I'm Joseph from IT2102, and for today's video, we're here to do a summary about Chapter 11, Build a Small Network. So, small network topologies. With small network, the design of the network is usually simple. The number and type of devices included are significantly reduced compared to that of a larger network. The network topologies typically involve a single router and one or more switches. So, this is typically a small business network. So the network so a single router and one or more switches, more switches, and then so in the receiving devices, the receiving or sending devices. So devices selection for our small network. So when selecting the type of intermediate devices, there are a number of factors that need to be considered. So first one is the cost. So the cost of switch or router is determined by its capacity and features. The device capacity includes the number and types of ports available and the backplane speed. So speed and types of ports, so interfaces. So choosing the number and type of ports on a router and a switch is critical decision. Expandability. Network devices come in both fixed and modular physical configuration. So operating system features and services depending on the version of the operating system. Network device can support certain features and services. So IP addressing for a small network. So all hosts within an internet network must have a unique addresses. So the IP addressing scheme should be planned to maintained based on the type of the device receiving the address. So this is an IP before addressing planning and assignment. So this is the West Office, East Office. This is how to plan for doing a small network. So we need a PC, printer, hub, and just like the same in the West Office. So redundancy in a small network. So a small network typically provides a single exit point toward the internet via one or more default gateways. So if router fails, the internet network loses connectivity to the internet. So for this reason, it may be advisable for a small business to pay for a second service provider as backup. So that's a cons. So traffic management. So the network administrator should consider the various types of traffic and their treatment in the network design. Routers and switches in a small network should be configured to support real-time traffic such as voice and video in a distinct manner relative to other data traffic. So prioritizing the traffic. So traffic sent to backbone in order to of priority. So traffic sent to router without any priority, and then backbone. So priority queuing has four queues. The high quality priority queue is always emptied pass. So the higher the faster, the lower the slower. So common applications, so network applications. Applications are software programs used to communicate over the network. So that's network application layer services. Other programs may need assistance of application layer services to use network resources like file transfer or network sprint spooling. So these network protocols comprise the fundamental toolset of a network professional. Processes on either end of a communication session, types of messages, syntax of the messages, meaning of the informational field, how messages are sent, and expected response to interaction with the next lower layer. This is the common protocols. Every protocol should be followed in order to have a good network and communication. So, voice and video applications infrastructure to support the system proposed real-time application. The infrastructure must accommodate the characteristics of each type of traffic. So, VoIP device convert analog into digital IP packets. The device could be an analog telephone adapter that is attached between a traditional analog phone and the Ethernet switch. So, IP telephony. So, in IP telephony, the IP phone itself performs voice to IP conversion. So, real-time applications. To transport streaming media effectively, the network must be able to support applications that require delay sensitive delivery. So that is the voice and video applications. Small network growth. So network communication. So physical and logical topology. Device inventory. List of devices that use or comprise the network. So budget, itemize IT budget including fiscal year, equipment purchasing budget, traffic analysis, protocols, applications, and services, and their respective traffic requirements should be determined. So this is the growth. So to grow, in order to a small network to grow, so this needs so network documentation, the physical, so the device inventory, the budget, and the traffic analysis. So protocol analysis to determine the traffic flow patterns. It is important to capture traffic during peak utilization times to get a good representation of the different traffic types. So perform the capture on different networks. So segments, some traffic will be local to a particular segment. Employee network utilization. These snapshots typically include information such as OS and OS version, so non-network network application, CPU utilization, drive utilization, and RAM utilization. So that is the employee network utilization. So this is type of threats information type when you're using somebody's information to example to withdraw from the another person credit card used by making a by stealing the information about the owner of the credit card. So data manipulation. So it's all about the data being being manipulated and being deleted. So identity theft is being is identity theft is I think it's make using other people's information. So the description of service. So will make you not to. So about disruption of service. Somebody will make the page overload so that others cannot use the service. So physical security. So this is the physical security plan. So plan physical security to limit damage to the equipment. Lock up equipment and prevent unauthorized access from the door ceiling, raise floor, windows, ducts, and events. So monitor and control closet entry with electronic logs with security cameras. So this is the physical security. But so secure computer room for floor plan. So this is for your security. So you can use this. So hardware threats, physical damage to servers, routers, switches, cabling plant, and workstation. Environmental threats, temperature extremes, too hot or too cold, or humidity extremes. So electrical threats, voltage spikes, insufficient supply voltage, unconditioned power, and total power loss. So maintenance threats, so poor handling of key electrical components, lack of critical spare parts, poor cabling, and poor labeling. So types of vulnerability, so network security weakness, TCP IP protocol weakness. So HTTP, FTP, and ICMP are inherently insecure. So SNMTP, SMTP related to the inherently insecure structure upon which TCP was designed. So, operating system weakness. So these are the cons of an operating system. So each operating system has security problems that must address. So, Unix, Linux, Mac OS X, Windows Server 2012, Windows 7, Windows 8, they are documented in the computer emergency response team. So TR, so network equipment weakness. So the weakness of network equipment. So various types of network equipment such as routers, firewalls, and switches have security weakness that must be recognized protected. Okay, so their weakness include password protection, lack of authentication, routing protocols, and firewall holes. So you should always use hard to guess password. So types of malware. Viruses, a computer virus type of malware that propagates by inserting a copy of itself into and becoming part of another program. So it is common. So worms, computer worms are similar to viruses in that they replicate functional copies of themselves and can cause the same type of damage. That is worms. So Trojan horse. Trojan horse is another type of malware named after the wooden horse the Greeks used to infiltrate Troy. So this is Trojan horse. Reconnaissance attacks. Reconnaissance attacks the discovery and mapping of systems, services, or vulnerabilities. Access attacks, the unauthorized manipulation of data, system access, or user privilege. Denial of service disabling of option of network, system, or service. That's denial of service. So, access attacks, so password attacks, so attackers can implement password attacks using several different methods. Brute force attacks, stolen host programs, and packet sniffers. So make sure your device is always has great security in order to avoid some hacking scenarios. So to get hacked. So denial of service attacks or DOS attacks. So resource overload, disk space, bandwidth buffers, ping flows such as smoke, packet storms such as UDP bombs, and fragments. So, malformat data oversized packets such as pin of death, overlapping packets such as video, unheld data such as teardrop. DOS attacks prevent authorized people from using a service by using app system resources. So it's very threatening. So just be careful on what you click on the internet. So because there are so many viruses there, and then different types of attacks can so you can have your laptop or your information. So just be careful. Click before you think before you click. So backup, upgrade, update, and patch. So keeping up to date with the latest development can lead to more effective defense against network attacks. As a new malware is released, enterprise need to keep current with the latest versions of an antivirus software. Authentication and authorized and accounting. So authentication, authorization, and accounting. Network security service provide the primary framework to set up access control on a network device. AA is a way to control who is permitted to access a network, what they can do while they are there, and what actions they perform while accessing the network accounting. So that's AAA or authentication, authorization, and accounting. Firewall, so packet filtering prevents or allows access based on IP or MAC addresses. Application filtering prevents or allows access by specific application type based on port numbers. So URL filtering prevents or allows access to websites based on specific URLs or keyboards. Stateful packet inspection. So incoming packets must be legitimate responses to requests from internal hosts. So firewall is very important. Protect your device from viruses and other attacks. Endpoint security, an endpoint or host is an individual computer system or device that acts as a network client. These are examples: tablet, laptop, cell phones, and many more. So device security overview. Default usernames and passwords should be changed immediately. Access to system resources should be restricted to only the individuals that are authorized to use those resources. Any unnecessary service and application should be turned off and uninstalled when possible. Passwords, use a password length of at least 8 characters, preferably 10 or more characters. A longer password is better password. So as I said earlier, so use hard to guess passwords. Make passwords complex, include a mix of uppercase and lowercase letters, numbers, symbols, and spaces if allowed. Avoid password based on repetition, common dictionary words, letter or number sequences. Usernames relatively or pet names, biographical information such as birth date, ID number, ancestor names, or other easily identifiable pieces of information. So just create a unique password that only you can know. So basic security practices, additional password security, strong passwords are only as useful as they are secret. There are several steps that can be taken to ensure that password remains secret. So enable SSH, so to enable it, so step 1, configure the IP domain name. Step 2, generate one-way secret keys. Step 3, verify or create a local database entry. And step 4, enable BTY inbound SSH. So this is the whole thing. So interpreting ping results. So using the ping command is an effective way to test connectivity. The ping command uses the Internet Control Message ICMP and verifies layer 3 connectivity. The ping command will not always pinpoint the nature of a problem, but it can help to identify the source of the problem. An important first step in troubleshooting a network failure. So that's interpreting ping. So we covered many times how to the ping. So this review. So extended ping. So the Cisco ISO offers an extended mode of the ping command. So this mode is entered by typing ping in the previous exact mode without destination IP address. So this is the extended ping. Network baseline. Creating an effective network performance baseline is accomplished over a period of time. One method for starting a baseline is to copy and paste the result from an executed ping trace or other relevant commands into a text file. So that is network baseline. So interpreting trace messages. So a trace returns a list of hops as packets routed through the network. The form of the command depends on where the command is issued. When performing the trace from the Windows computer, use tracer. When performing the trace from a router shell, use trace route. So that's interpreting trace messages. So extended trace route. Design a version of trace route command. The extended trace route command allows the administrator to adjust parameters related to the command application. So that is all about extended trace route. So common show commands revisited. So the Cisco IOCL show commands display relevant information about the configuration and operation of the device. Some of the more popular show commands are show running config, show interfaces, so show app, show IP route, and show protocols, and show version. So that are the show commands. So common show commands. The ARP command. The ARP command is executed from the Windows command prompt as shown in the figure. So the ARP-A command, this all devices contain the ARP cache of the host, so which includes the IPv4 address, physical address, and the type of addressing for each device. So that's the ARP command. Common show commands, the show CDP neighbors command. CDP provides the following information about each CDP neighbor device. So first one is device identifiers, for example, the configured host name of switch. So this is the example. So just type in the previous example this switch as the host name, then indicate the name of the host name. So address list up to one network layer address for each protocol supported. So Port identifier, the name of the local and remote port in the form of the ASC2 character string, such as patch internet 0/0. Availability list, for example, whether this device is a router or a switch. Platform, the hardware platform of the device, for example, a Cisco 1841 series router. Show IP interface brief command. So verifying router interface, one of the most frequently used command is the show IP interface brief command. This command provides a more abbreviated output than the show IP interface. It provides a summary of the key information for all the network interfaces on the router. So that's the purpose of show IP brief show IP interface brief command. The debug command. So all debug commands are entered in the previous segment. Cisco iOS allows for narrowing the output of debug to include only the relevant features of sub-features. So this is the output for the debug ICMP command. So just type on the exec mode is the debug IP ICMP. So will indicate the ICMP packet device on, and then the information will be given. Basic troubleshooting approaches. So common and efficient troubleshooting methodology is based on scientific method and can be broken into 6 main steps shown in the figure. So step 1, identify the problem. Step 2, establish a theory of probable causes. Test the theory of determined cause. And 4, establish a plan of action to resolve the problem and implement the solution. 5, verify full system functionality and implement preventive measures. 6, document findings, actions, and outcomes. That's the basic troubleshooting approaches. So verify and monitor solution. So verification tools include the ping, trace, root, and show commands. The ping command can be used to verify successful network connectivity. So as I said in the previous chapters, pinging. So when the other network replies, so it means that the network connectivity is good and the configuration is good. So duplex operation. In data communication, duplex refers to the direction of data transmission between two devices. Two communications are restricted to the exchange of data in one direction at a time. This connection is called half duplex. Full duplex allows the sending and receiving of data to happen simultaneously. So we can know that in this duplex operation, we can know the difference of half duplex to full duplex. Duplex mismatch. Duplex mismatches may be difficult to troubleshoot as the communication between devices still occurs. Duplex mismatch may not become apparent even when using tools such as PIN. Single small packets may fail to reveal a duplex mismatch problem. So that's the duplex mismatch. IP addressing and issues on iOS devices. So IP address related problems will likely keep remote network device from communicating. Because IP addresses are hierarchical, any IP address assigned to a network device must conform to the network's range of addresses. IP addressing issues on the end device. So in Windows-based machines, when the device cannot contact a DHCP server, Windows will automatically assign an address belonging to 169.254.0.0.16/16 range. This process is designed to facilitate communication within the local network. That's all about IP addressing issues on end devices. And then default gateway issues. The default gateway for an end device is the closest networking device that can forward traffic to other networks. So if a device has an incorrect or non-existent default gateway address, it will not be able to communicate with the devices in the remote network. So that is the default gateway issues. Like I said, default gateway is very important. So without the default gateway, we cannot communicate with the devices in the remote networks. Troubleshooting DNS issues. Domain name servers defines as automated service domain names such as www.cisco.com with the IP address. While DNS resolution is not crucial, device communication is very important to the end user. So that's troubleshooting DNS issues. So yeah, it's all about my summary about chapter 11, building a small network. So I hope you learned from me. So thank you. That's all, and thank you for watching. Until next time.